All right. Hello, everyone. Welcome to the July 2025 session of Build It with Arduino Meetup Group. And today we are going to start diving into RC vehicle conversion to Arduino. And first of all, I want to share my PowerPoint here. Okay. All right. So in general, let's see. The online recording statement that I do recording and I do posting of these monthly meeting recordings onto the group YouTube channel. And so this is just a general disclaimer stating that. And then there is a general code of conduct that is officially on the Discord server under the rules channel. And so we all need, I ask all of us, of course, including myself, to be respectful of others. Okay, so that's it for that part of the explanations of how things will proceed and get started today. So I want to follow the agenda that I posted for the meeting today. And first of all, open it up to questions from the previous session that people wanted to bring forth and to discuss. So nobody has anything to discuss from last time? That's kind of surprising. I hope people want to start participating a little bit more. It's a little disconcerting on my part that because I put a lot of effort into the prep of all these, let alone actually hosting these events. And the whole premise of starting this group and having these on monthly installments is so that I'm not just up here talking, but I want to try to encourage everyone that attends these to actually be building something. And so that's why I started last month the official announcement, hey, we're going to do a group build that will allow for multiple areas of investigation and learning. And so I hope people going forward will want to participate in that project at some level and actually be building something offline and also within these 2-hour sessions and actually be bringing their questions, their progress that they are making on their build and actually be doing some show and tell of what it is that they're doing. And like I say, interacting more because this is, like I say, this is a little of concern to me right now in this stage of the group of where we're at with that. So I sure hope that that changes here very, very quickly. Otherwise, the state of this group is very much in question. Okay. So enough on that. Okay, well, then we'll move on to the material then. First thing I want to do is talk about some basics of hardware interfacing. So first of all, hardware interfacing for any microcontroller, not just Arduinos. The whole idea, of course, is to be able to have the Arduino programmatically and electrically control some sort of hardware, whether it be an IC chip that does some specific function, whether it be a sensor or a group of sensors. So that's what the idea of hardware interfacing all has to do with. And in general, speaking of the Arduino, there are digital inputs and outputs. there are analog inputs and outputs. Those are the two main categories. Plus the idea of connectivity of hardware to various communication programs, whether protocols, whether it be I2C, whether it be SPI or serial. And so those are the various ways electrically and programmatically that you hook things to an Arduino. And then on top of that, then you can, depending on what it is that you're interfacing, a lot of times you need to have an intermediate level of hardware and software that kind of sits in between. So you've got the hardware, say like on the leftmost part of a diagram. You got the hardware piece that you want to interface. And then you've got a cloud, like I'm just going to call it a cloud, to do with some glue logic that has to be in there to interface the Arduino pins or I2C, SPI, etc. Communication method, the way that that's electrically connected. You need sometimes to have that intermediary to do the to either, well, to make everything work together electrically and programmatically. So I know that that's just kind of a general statement that I just made, but going forward, we'll be investigating really what that means and looking at when, how, and why you want to have that intermediary level of development and implementation, and when you don't need it. Okay, so back to the idea about inputs and outputs, the actual pins that are sitting on an Arduino board. So digital wise, you can connect buttons like push buttons or toggle switches, LEDs, by using the digital I/O pins. And you typically do that using the Arduino language digital read and digital write commands. And basically, the digital pins on the Arduino are for simple on-off control or data transfer of some kind. And the whole idea of digital is that there's only a 1 and a 0 or a high or a low that's involved in the digital the digital communication and the states that that particular piece of hardware can be in, versus analog I/O. So typical pieces of hardware that come under the analog category: potentiometers, analog sensors, and for example. And so with the Arduino language, you use analog read and analog write. And typically pulse width modulation is involved in all of that. And so you use the analog pins to read sensor data, like potentiometers, thermistors, those types of sensors and parts. And the idea of analog is that there's a range of values, not just one and 0, that the device that you're reading or writing to can be in. That's why you have analog I/O. Now, on the hardware side, part of what we need to electrically satisfy a hardware electrical hookup to Arduino for a particular part is the consideration of what's called pull up and pull down resistors. What are those and when do you use them? A pull up and pull down resistor is used for digital circuits to ensure that a known defined voltage level at a particular pin, a digital pin, is established when no other signal is present. That's just kind of a basic electrical engineering / hardware interfacing concept here and rule that we have to follow. A pull-up resistor connects the digital pin to a positive voltage. And on the Arduino, it's typically 5 volts. Sometimes it's 3.3 volts. While a pull-down resistor connects that pin to ground or 0 volts. And the whole idea of these resistors being physically added to your electrical setup is it prevents floating of inputs, where the pin's voltage could be unpredictable if that resistor wasn't present and cause errors in as far as either like having to the Arduino being, say, reset unexpectedly, or some other fatal error on the controller side, on the Arduino side, could happen if those resistors aren't present, or other read-write errors that could occur if those resistors aren't in there. So the idea is, so I hope that that's clear about the use of pull-up and pull-down resistors. Now, so let's talk a little bit about hardware parts. Let's talk about ICs of one type or another, for example. Say like something like a 555 timer, or a single IC for like a motor controller, something like that. So so you need to understand when you want to hardware connect that piece, that part to the Arduino, you need to study the pin mappings and specifically the data sheet for that part. And so you need to build some skills, if you don't already have them, to interpret data sheets for interfacing. And you need to understand the summary on that data sheet, the pinout, the electrical specifications, and look for application examples, either hardware and hopefully some software examples that are provided. Those are always nice to have. And the summary provides like a high-level overview of the component functionality, while the pinout details which pins are for power, for communication, etc. You need to follow this stuff to the T to really interface that part to the Arduino. Electrical specifications like absolute minimum and maximum ratings, current and voltage requirements for the part are critical. And I don't mean just ICs. I mean any kind of sensor or anything that we want to interface. It's important that we know that details. Otherwise, we could easily damage either the part or our Arduino board if we don't follow the rules that are set by that part. And the examples that I just mentioned can provide tutorials, so to speak, about reference designs that we can borrow and reuse for our particular Arduino application. So you want to understand those pinouts and pin functions that are present. And of course, the electrical specifications are extremely important. Knowing what the voltage and current requirements are, and the power consumption requirements, all that, as far as like connecting battery power. So in general, as far as interfacing any of these parts with an Arduino, you use digital inputs and outputs, you use analog inputs and outputs, or direct communication channels, protocols, specifically SPI, I2C, and serial or UART. And so whenever you're shopping or you're retrieving from your stockpile in your workshop a particular part, you need to understand all that. You need to understand what the communication connectivity of it potentially is to the Arduino, and you need to do a deep dive research and analysis of that data sheet even if it's just a real simple part. You need to make sure that you know what you're working with. And the data sheet and hopefully some hardware and software examples that are out there for that part are extremely helpful, especially for a novice in doing this type of work. Okay. And of course, another electrical part on that data sheet that's extremely important to understand, besides the electrical specs, is the pinout that is present and how that will guide you to actually connect that part to the Arduino. Okay. So in general, you connect your part directly to an Arduino using one of the analog or digital pins, I/O pins that are on the board, and access it directly by digital or analog commands that are provided to us within the Arduino language, or communicate with it via a connection on the Arduino board for I2C, SPI, or serial UART. And as I mentioned before, for some parts, some circuits that we build that will really come into play with this RC car project that we are starting on, you will frequently need a glue circuit to interface that part into the Arduino. And that is primarily for current and voltage that is required by the part. Part of what also hardware wise that we need to look at is understanding our particular Arduino board as far as what its IO limitations are. Because on any microcontroller system, there are, if we're specifically looking at the IO pins, there are limits as far as how much source and sink is what it's called of current that can be present on any one pin or on any group of pins that you are interfacing on that board. And so that's another part of this understanding whenever we're doing hardware interfacing, that we need to not only understand the specs and the data sheet for the part that we're interfacing, but we also need to understand the totality of the Arduino system, that board that we're interfacing to. And so that glue logic helps to bridge any limitations for current, especially current needs that interface that part onto the Arduino. So enough on that topic right now. As far as hardware interfacing, we'll be getting more into, I wanted to just give you guys a basic overview today on hardware interfacing. And then at the end of our discussion today, I'll upload some PDFs for some particular hardware interfacing exercises that I suggest of interfacing some common parts and sensors directly to the Arduino. Those samples will contain not only the schematic, but also some sample code that you can follow just to cement some of these ideas that I've talked about here as far as how to adequately interface hardware. Okay, so the next thing that we're going to do now, we're going to actually start getting into the let's see, actually, why don't we go ahead, why don't we take a brain break here, like a 10-minute brain break. And then we'll get back, then we'll start actually talking about motor control methodologies. Okay, so let's take a 10-minute break. Okay.
Hey, Donna,
Yeah,
can you hear me?
sure. Yeah,
Yeah,
yeah.
sorry about the lack of participation, but I'm actually pretty well along building my robot even before this series, so maybe why I haven't been participating as much as um, and a lot of the things you mentioned, I've actually done. It's like, it's like I look back and I say, oh, Donna recommended that, and I had already done it. So a lot of your suggestions are right on the money. So I'm just kind of starting my journey at this point. Just I have a lot of experience in electronics, but not so much building robots. So a
Right.
lot of things you're saying, like starting out with an existing robot and then tearing it apart, using that. I did exactly that. You know, and
That's cool.
that was like a year ago. I'm
Hmm.
still working on it. So
Yeah. Oh, yeah.
um,
No, I don't. Well, this is a that's one of the things to me that's so fun about electronics and programming and robotics, really, as a whole, is that it's not just a series, say, of individual projects or sub projects to do something, but it's a whole journey. It's a great learning and exploration journey that we're all on as far as merging programming, electronics, for whatever it is that we're controlling. In this case, with Arduinos. So I'm glad to hear that, Doug. That's good to hear. Thank you for your input on that. So, by the way, Doug, it would be great, uh, you know, since you are further along, than maybe than some of the other folks here, is that maybe you want to start doing. That's part of what it is. I want to open up for everyone is like show and tell time.
sure.
Show us, actually do like some demos of where you're at in your project, some of your lessons learned, some of just kind of demo of what it is that you've been doing, because that's a great way for all of us to learn and to be sharing information. That's part of what it is that I want to foster in this group. So, you know, I'm
Yeah,
not
I can
necessarily
definitely
today during the Q&A, but you might
sure.
want to do that too.
Yeah,
But
I'm working on a self-balancing robot,
oh, great.
and yeah, I've been having some trouble getting it to stay up, but you know, so yeah, any suggestions on that? You know, I can give you a demo of what I have. Yeah, that would be great.
Great. Okay. Yeah. So anyway, that's just something for all of us to be uh steering our efforts towards within this group. So
Donna, I don't know if you saw my bit of I did a write up on the resources
I
section.
did. I right
Um,
before the meeting, I was taking a glance at that.
so what I did is I bought a couple of cars,
Hmm.
and I mentioned there that about what 24 years ago I had done something similar. Actually, another person had bought the cars and wanted me to help him hook in a microcontroller. We at the
Hmm.
time were using a basic stamp, and
Hmm.
uh, so we opened up the car, and what we found was a pretty good sized circuit board that had a lot of discrete components. So
Hmm.
I diagrammed the circuit, and from that we figured out the protocol between the transmitter and the receiver. It was a
Hmm.
very strange protocol, designed around using as few parts as possible, I guess, when you're
Right.
hand building something
Right.
with discrete components. And so I was able to identify an 8-bit register, as I recall, and then we just cut and slashed the traces on the outputs of that register, and then we fashioned a ribbon cable so that that ribbon cable could be soldered on either side of those cuts and slashes, and so that then we were able to and then the other end of the ribbon cable was soldered right across the connector of the basic stamp. And so that allowed us to have each of those outputs go to an input on the basic stamp, and each of the outputs of the basic stamp to go and drive what that register used to connect to. And then
Hmm.
the first program we wrote in P Basic on the basic stamp was as fast as you can, read the inputs and write it to the outputs, and just keep doing that over and over again. And
Right.
then we were able to test that by playing with the remote control and see how well it worked.
Hmm. Hmm. Right. Yep.
So I had that idea to as my first thing that I would do with this new RC car, but as soon as I opened it up, I realized I'll have to do something else because instead of a whole bunch of discrete components, this one just has a single chip that does the radio receiver, and that
Mm-hmm.
is a 2.4 gigahertz receiver with automatic pairing
Mm-hmm. Mm-hmm.
and it has the motor controller, so it's all on the one chip.
Mm-hmm.
So I
Yep.
get the best I can do is try and present a an appropriate load to those motor controller outputs so that that chip is happy, and then measure hopefully digital signals from those outputs that I can use so that the Arduino will know what the RC car controller is sending. Uh,
Mm-hmm. Mm-hmm.
and then I'll have to get some sort of other motor controller to drive the motors. Um,
Mm-hmm.
so uh, I guess my next step is to figure out uh, what what kind of a motor controller I need. And I thought a brute force way to do that would be to put an ammeter in series with the battery and just see what the current maximum is, and that would give
Mm-hmm.
me a
Yep.
good
Yep.
limit for the individual motors. It'd be about
Yep.
twice as much.
Exactly. Yeah, I talked about that. Doug, I talked about that during our last meeting
Hmm.
about the way to be analyzing to figure out what kind of motor controller that you need. But yeah, that in my view is the best way to be looking at that. Anyway, Doug, specifically to your points, where it is that you are on your conversion journey, that's part of what it is we're going to be talking about here this afternoon.
Oh,
As
okay.
far as motor control methods, I want to open the floor for your thinking on ways to be doing that. So we might as well. We're all just kind of hanging out here. Why don't we go ahead and get started on doing the getting into motor control methods? Okay, that I wanted to talk about today. Um, okay, so so the idea here is I'm going to suggest two different ways to think about modifying any kind, hopefully on the cheaper side, not a high-end or remote control vehicle, but on the cheap side, um, of modifying that vehicle to Arduino control. There are two main methods that I want to mention today. First of all, we need to start here making the decision as far as motor control is paramount at this stage to convert to Arduino, since everything else that we do for this project really depends on what it is we decide at this stage. That is why we're starting here where we are as far as motor control methodology. So what you can do is you can choose between both remote control, in other words, wireless control of some type. You can control your vehicle that way and autonomously. In other words, you can have a user control switch that you enable or disable that will allow the remote control method, or with that user switch in the other position, you can allow for our autonomous control. So that's one way. That's personally what it is that I'm doing with my cheap remote control vehicle. Is going to go with implementing it that way for motor control. The other is autonomous control only. In other words, completely wipe out any remote control that is on the car or on the truck. Okay. And just go with Arduino, in our case, giving autonomous control. In other words, programmatic control. Okay. So those are the two choices that we have for motor control. Okay. And autonomous control refers to not only the Arduino drive functions for the motors, but also logic control for any attached and all attached peripherals on the boards and the vehicle platform itself. when the vehicle is in remote control mode, all drive actions are handled by the user controlled handheld device. Okay. When in this mode, the standard is to only control vehicle drive control. But for a more sophisticated RC systems, a lot of actuators and other functions can be controlled by the transmitter. So for instance, with my little cheap RC vehicle, I have this is an old Radio Shack truck that I'm going to be modifying for this particular project. And this had just a standard, this is a 49 megahertz original style remote RC control. So this is what I mean by when it's in RC mode for this particular vehicle, everything is controlled by its controller device, okay? Versus autonomous, where its thinking brain is doing all the drive for the vehicle. So that's what it is that we need to be looking at here. So let's first of all talk about the easy route here for motor control. I mean, easier, the easiest, where we're talking about autonomous control only. Okay. So I'm just going to give a general overview as far as what a person needs to do to modify your target vehicle for Arduino control only. So what you need to do is remove now what I'm talking about here for a cheap vehicle is that usually in that case, there is no formal standard RC standard parts that are on it. What I mean by that is that there's no RC receiver unit that's on the car. It's instead all on the cheap. The receiver is all, and other control electronics are all on a PCB board that's mounted onto the vehicle. That's the cheapest way that a remote control vehicle is produced, okay? Because it's cheapest for the manufacturer, okay? They don't have that extra cost of purchasing and installing a standard remote control receiver unit. So what you need to start with is physically removing the existing PCB board that includes the motor driver circuitry and the RC receiver. That's what is on that PCB. So in my case here is a front with its top taken off. Here is a PCB board that I refer to. This contains the motor for both the rear drive motor right here, and for the front steering motor here. Okay. It includes the motor drivers for RC controller, transmitter control of the vehicle, and also the RC receiver functionality that decodes what the transmitter is downloading into the board, and then it decodes those signals and transmits those commands over to the drive and to the steering controls. That's what this board does. And that's what I refer to, that you need to move that board. And you have to make careful notes of what connections and where before you start cutting wires to actually uninstall that board. So that's a very critical thing to do, is to make a thorough diagram of what is where and how things are connected. And then once that's out of there, then that included remote control transmitter unit is no longer applicable. Okay. And then as I say, you need to start a schematic of the platform, motors, actually, in this case, all those connections. And then after the PCB is removed, you need to extend all those wires to the steering and to the drive motors to allow for new electronics, the Arduino board itself and the motor controller board, okay? And for ultimate mounting onto an attached deck. Like in my case, I have a deck that I am starting that literally fits on top of the platform board itself, where the Arduino will be mounted here along, and then the actual other boards, support boards for the system, will be in other areas of this deck. So that's the type of thing that I refer to there. And so you need to take some time and really diagram things out and start noting colors of all the wires. And part of this is decoding the especially so a lot of times, like for this platform that I've got. Okay, so the drive motor is just a real simple, this is a 6 volt, 5 or 6 volt DC brushed motor. Okay. And yeah, brushed. And so this is a real easy interface to a motor controller board, and then ultimately to the Arduino. But this little guy here for the steering motor, let's see, this is a special contrivance that this manufacturer implemented for cheap control. This is not a standard servo by any means. This is actually a small, likely a dual to this motor here. Okay. This is a geared contrivance that provides something similar to a servo for steering. Okay. But it's really a DC motor. And so one of the things that you need to do when you're taking all this stuff apart, part of the decode to understand the controller requirements and all that, is to actually get in with a voltmeter and that kind of thing to actually check what the control signals are for this steering motor. So that's part of what we need to do anyway for any of this motor control decisions that we're making, is that before we start cutting wires, we need to get in and we really need to understand the two motors that are on your platform of really what the control logic is, what the voltage requirements are, what the voltage requirements are for the vehicle in total, and then also what the voltage and current requirements are for the two individual motors that are on your platform. So that's going to take some time to do, and probably next meeting will be diving more into that as far as actually doing that work. But I'm just letting you know about the type of thing that's in front of us with actually doing the disassembly of what it is that's actually on the unit itself, on the platform itself, to be able to successfully add an Arduino for the control. So that's really important stuff to be knowing ahead of time. Okay. As I say, that front steering motor is usually the sticking point as far as starting to understand the way that the platform works, the way that the platform controls are, the way that the remote control interfaces with the platform. Okay. And then we also need, okay, so you need to understand what the voltage and current requirements are. I already talked about that. The platform as a whole, and then the requirement for the motors. Okay. And that just is a situation where we take an ammeter and we actually, a voltmeter. Okay. And then we start doing some measurements when we have our vehicle up on a stand where it can't move, and we have our remote controller device in our hand, and we are doing checking literally as far as what kind of signals, or an oscilloscope if you have access to that, that we actually get in and we do physical measurements to know how that device is being controlled, so that we can then take that PCB that's built onto our cheaper vehicle, remove that, and then substitute in a compatible hardware, motor controller board that will ultimately be hooked on, interface to the Arduino board. Okay, that's what it is that we are looking at here for motor control interfacing. And then you also want to be aware, so on my particular platform, this is just a standard set of 4 or 5 AA batteries that this little car or truck requires for the vehicle power supply. Okay, so what you do is you plug that pack into the bottom here. Okay, but then so that's the way that the motors, ultimately, that's going to be the power source. Once that we remove this, or once I remove this PCB and I substitute it with the motor controller board, this pack that I refer to is going to be the power source to the motor controller board. That's going to be a big part of the hardware design for this device, is that the platform power supply pack is what goes to the motors. But you always want to, whenever you're doing a project like this or any kind of embedded programming, especially like with robotics and this type of vehicle, is you need to have you want to plan on having 2 power sources. You want to have a second power supply, usually voltage regulated, that provides not only the motor drive requirements for current and voltage, but then secondarily providing a 5 volt, typically 5 volts or sometimes 3.3 volts power supply that is just for the electronics. So just for the electronics refers to the Arduino power source itself, along with all of the sensors and that will be added to this unit over time. So that's just a general kind of electrical engineering type of methodology that we want to employ, is having 2 separate power sources. That way, power spikes and interference of noises that happen on the platform, specifically with mostly with motor control. Motors can be very noisy electrically, and they can easily interfere with delicate electronics like an Arduino board and sensor functionality. So we will always want to have 2 separate power supplies. So you need to plan that in with your initial thing that you're plan that you're doing for your vehicle, and also plan for that on your mounting scheme on your device. Okay, so these are kind of FYIs that I'm giving you, and need to know information to move your build on. Okay. Okay, so you need to, I already mentioned this, you need to look at both the drive and the steering motors and really understand this is probably going to be your biggest time sink for getting all this going, is to understand, do measurements, do careful reads of the specifications and stuff that came with your vehicle, all that kind of stuff, to really understand what the requirements, voltage and current wise, are for your 2 motors, for the steering and for the drive motors that came with your vehicle. And then you need to, once you understand what the voltage and the overall current needs are, Doug already mentioned this about putting an ammeter in series on the positive rail of the power supply of the vehicle that goes to the drive and then subsequently to the steering motors, to actually measure what the current requirements are for that vehicle whenever it's actually under load. That's going to be your best gauge to understand what the current requirements are for when you go and you buy a motor controller or motor controllers, depending on what you get, for actually to that will be used on your vehicle. So once that you do your analysis as far as understanding how your vehicle is hooked up for RC control, you do your diagramming, you do your removal of, if that's the choice that you decide to do for motor control of autonomous only, you go ahead and you do a removal of the PCB board that's on there. Okay. And then you once that you know what you're dealing with on the vehicle, then you go and you buy the motor controllers. So the reason why I say motor controllers plural is that some of them that you buy will only control one DC motor. Others are designed for one board to be able to drive two motors. Okay. So you need to be aware of that whenever you're going and you're shopping. We talked about some potentials last month, the suggestions that I had for where and what you buy for motor controllers. And then you have another big part of this is to know which Arduino board that you want to use on this platform. Usually the Uno is sufficient for this type of project because of the amount of code that can be programmed onto the board itself and the number of IO pins and SPI availability, I2C, and UART that is on the Uno. Usually an Uno is sufficient for this type of project, okay? And so you have your motor controller, you have your Arduino, you have your platform that is partially hacked at this point, and then you start the physical layout and cutting and starting to mount your deck, your wood sheet deck, and start to arrange your various parts onto your platform. And then we're going to be moving on from there as far as actually starting to wire and then program how everything is going to be working together. So that's kind of the overview of the steps as far as actually hacking your vehicle. Okay. Now, the other thing that is important here is to be looking at option number 2, where you have the user selectable switch control that can either enable wireless or the RC for remote control that's already on the platform, and either have that enabled or the autonomous / Arduino control. That is the method that I'm doing on this little vehicle because it's more challenging. Okay, and that's why I chose to do that. So what you're doing is you're keeping the PCB board on the device. And so then what you need to do, this is more complicated because it requires additional hardware. Remember during the hardware interfacing section, I talked about glue logic. This is a key example of when your system needs glue logic. Okay. We're going to be getting into all this if people are like me and they decide to implement their modifications using this methodology. Okay. So, okay. Okay, so what you can do if you wanted to have this, now we're talking about standard RC protocols here. There are other methods besides remote control industry, okay, wireless technologies. But right now I'm just going to be talking about this in terms of the standard remote control vehicle standards of a RC transmitter, an RC receiver, and to interface with RC industry wise to interface both of those components with motors, they use what's called ESCs. Okay, so those are the main components RC industry wise that we are talking about here for the RC components that we may want to keep for our ultimate control scheme. Okay, so what you can do is you can keep, this is what I'm going to be doing. I'm going to be keeping my default PCB that has both the motor control and RC receiver right on the board itself. What I want to do is keep that intact as much as possible. Okay, and then just add to it with the autonomous control. That's the scheme that I'm going to be implementing. Okay, for this harder, more complex control system. The other thing that you can do if you want to have this user selectable control is you can take out that PCB board that came with your cheap vehicle or inexpensive vehicle, excuse me, that's a better term to use here. And you can remove the PCB board and replace it, remote control standards wise, with an RC, standard RC receiver. And then use a comparable or a workable transmitter and ESC, where all three of those RC standard wise are all automatically compatible together. Now that's going to be a little bit more expensive of an option because you likely need to buy separate components. You need to buy the ESC that works with your vehicle and your RC control system itself for the receiver and the transmitter. Okay. So that's just an FYI there. But in general, if we're talking about standard RC control, those are the things that you need. You need whether we're talking about 2.4 gigahertz RC or not, or we're talking about the old style 27 megahertz, 47 megahertz, I'm sorry, 49 megahertz, old style RC systems. Regardless of that, you have a standard set for RC control that is the de facto plug and play set of components that are interfaced onto an RC vehicle. All right. And so you have the RC transmitter, RC receiver, and then the ESC. Now that ESC, one or more of those are what electrically connects that RC receiver that is sitting on your vehicle to your one or for each of the individual motors that are on the platform. Those ESCs are what in a plug and play box or board, so to speak, that is the electrical hardware part that is that's used in this whole system. Okay. So because all three of those parts need to work together if you decide to go that way. So, if you're not, well, anyway, depending on what you want to do with this vehicle, you have two options for this user selectable part component of this design. Is that you can either use the existing PCB that's on the vehicle, or you can literally tear that out and then rewire the drive and the steering motors in with ESC receiver, RC receiver, and then a RC transmitter. Okay, those are the ways that you can do the RC standard control part of this modification. Okay, so that's step number one for a user selectable control scheme. Okay. And as I say, you don't need to use necessarily RC standard technologies. You can go with other wireless communication systems. There are multiple ones that exist. For instance, Bluetooth, and or Wi-Fi plus handheld controller, like a joystick or a phone app, a cell phone app. Those are typical. You could use an XB system Okay, like XB controller and receiver pair, plus a joystick, or the traditional remote control industry transmitter and receiver combination. So there are, and I'm sure that there are more wireless technologies than what I just gave in that listing. But you need, regardless of which of these is chosen, you need a technology, a tech choice compatible motor controller hardware piece, either ESCs or general motor controller board. The motor controller board that I'm using for my system, maybe here it is a Seed Studio. This is a dual motor, DC motor, brushed motor controller board that is directly Arduino compatible. That is the board that I'm going to be adding in with my system. Okay. And so the idea here, this one of the reasons why this is more complex, besides everything that I just went through for your options, is that you need glue. You need hardware glue to make everything work together. Now, why do I say this? Because whenever you've got, so what happens in a dual control system is that you've got resources that are being shared here. The resources on the platform that are shared between autonomous control or remote control are the two motors. That's a shared resource in a hardware software context. And we need to prevent what's called resource or bus fights of those shared resources. And so you need to have a more complex hardware software system to prevent those fights, because otherwise things are going to go awry in a really fast order if you don't handle things that way. That's going to be coming at the August session, where we'll actually get into how to prevent those resource fights and how to actually design your system from a hardware standpoint to allow for either autonomous control or some sort of wireless control of your device. So that's what it is that we're kind of looking at here. And for whenever you're talking about these more complex control systems, likely an Arduino or an Arduino Uno is not going to cut the cake here, because of the lower number of I/O pins that are on an Uno. It's probably best to go with an Arduino Mega, okay, for such a system. So that is kind of the overall context here. I know that I talked about a whole slew of things in a really fast order here. I understand that, and this can be quite overwhelming. But I just kind of wanted to shoot the playing field out here as far as the types of things that you need to be thinking about, either from a financial standpoint, as far as the type of money that you have already invested into purchasing your vehicle or vehicles, and in your Arduino supplies that you've already put together for yourself, and then where you want to take this, as far as your explorations and ultimately what you want to do here. Because we need to start this conversion project looking at the motor controllers and looking at how you ultimately want to build this system out. Okay. Okay, so I'm encouraging you to make your choice. Make your choice between a remote control / autonomous control strategy for your motors, and how that one is going to work by a user selectable switch, or just autonomous only. And then regardless of which one of those that you choose, you need to, if you haven't done so already, you need to go out and purchase your motor controller boards. And those are the main things right now that I'm asking you to look at and plan and consider. And then over time, then we'll start adding in other hardware sensors and other hardware resources to build out this RC to Arduino vehicle conversion. Okay. And like I say, at the August meeting, we'll start looking at the hardware and software interfacing specifically of the motors on the platform, and start detailing all that and really starting to put the rubber to the road here as far as implementing this. Okay. So at this point, I kind of want to open things up for your general questions. You know, this is going to be kind of like a show and tell, showing, maybe showing to the group as far as what it is that you purchased for your vehicles. And Doug has already talked about that a bit as far as what he's done and in the process of doing. Doug has talked, the other Doug H, has talked a little bit about where he's going as well. And Kinsley, you've got your hand raised. Please, you've got the floor.
Hello. Okay.
Yep.
So I am pretty new here, and unfortunately, I do not have a RC board. I'm just here to observe. Um, and also I heard that you also have there's a Discord meeting, or a Discord group, which I'm not part of. I heard that it also has all the information that you are talking about, and also this meeting is also published into YouTube. So I was wondering whether I could have access to the Discord
Okay.
meeting.
Right. Okay. So let Kinsley, first of all, I and we welcome you to this group. So I'm glad that you're here. And specifically, whenever you on Meetup, okay, Meetup is the central repository, our main channel point for everything for this group. Okay. And that's directly tied to these meetings, these monthly meetings. Okay. So we meet, you likely know this already, but we meet on a once a month frequency. Okay. By Zoom. We always meet by Zoom. Okay. So in the on the Meetup group itself for Build It with Arduino group, on the home page of the Meetup group itself is a description. It's literally on the home page of the group. There's a description in there of what we're all about. I don't remember what the title of the section is, but there's a what we're all about or an about us area that I've got detailed on there about the group. So if you click on that more link, you will see the totality of the text that I've got there about everything about the group. So on there at the bottom of that section are two hyperlinks. One is a join link to join the Discord server that you already mentioned. And then the second link is a direct link over to the YouTube channel where all of the monthly meetings are stored. So that's the way to actually get in and fully consume the information. And then whenever you RSVP for every one of these monthly meetings, then automatically, once that you've RSVP'd, you get access on your account page of Meetup. You get the actual Zoom joint link. So that's the way that all of that works. Okay. And in general, on the Discord server, if I recall, is where I put in the resources channel. There's multiple channels within the Arduino Discord server. It's under the resources tab that I put all of the resource materials that are associated from one month's meeting to another. And then, of course, one of the great things about the Discord server is that between meeting discussions go on there. sharing of content and resources, all that the members are participating in on the Discord, along with my commentary and answering the questions, etc. So that's the best way to participate outside of these between meetings, between these meetings every month. So does that answer your? So that should give you what you need, Kinsley, for the resources access. Okay.
Okay. Yeah, I was actually trying to, go through what you said, the meetup website, and I'll let you know when I actually find those links.
I'm sorry, Kinsley, but your audio connection was real it was hard to understand you. Um, maybe maybe you can restate your question.
Sorry about that. Can you hear me now?
I'm sorry. Does anybody else have that audio problem with Kinsley, or was that just me? Okay, well maybe it was just me.
Yeah, I could hear him fine. I think he was just thanking you for and was going to get back to you on whether or not he was able to access that material.
Oh, okay. All right. Okay. Okay. What else do people have? Is it we've got little less than an hour together if we want to use it. Like I say,
Oh,
I want to encourage participation by everyone. Okay, I know that we're real early on this project journey, but I'm hoping that people are excited about this. I hope that people find value in doing this project together and actually learning together, learning in a experimenting on our own to actually do the purchases and start doing the hardware and software hookup for all of this to make your vehicle work with Arduino. I hope that people are excited about this. I know that I am, but like I say, I'm a little I'm a little concerned of as far as the longevity of this group if we don't start getting questions and active participation as far as show and tell and willingness to share your projects, all of that. So that's the whole goal of why it is that I'm doing this and why I'm putting the time and commitment on a monthly basis to this group. And if people aren't willing to share and work through the stuff with me, well then I don't see why I should be here. And so like I'm just stating that as a fact, as far as the longevity of this group. So whatever you guys want to do on that score, I will take to heart. And perhaps at the beginning of 2026, this group will no longer be present if we don't start changing this going forward. Okay.
I'll do a bit of a.
I'm not trying to blame anything or anybody. I'm just trying to state the commitment that I'm putting into this, and I just expect some reciprocity from the membership. Okay. Enough said on that.
I'll do a bit of a show and tell. So last time I said I'd
Ah, okay, Graham. Okay.
actually went ahead and bought a USB shield. So I got it on my Mega board. So it allows me, I have a PlayStation controller. I can actually plug it in via either the USB directly into the board,
Okay.
or I have a Bluetooth dongle. Where'd it go now? That I can actually plug into it, and then it'll work wirelessly through Bluetooth, so I can
Okay.
control the motors. And the library for this shield is quite good. That I actually I think there was only maybe a code or two I had to change to specify what port or something connects that, and all the buttons, joystick, everything works on the PlayStation joystick. And I think there's one for PlayStation 3, PlayStation 4, Xbox controllers. The code's already all written. One device that wasn't written is that I have a Tony Hawk skateboard.
Ah.
So it works with the PlayStation. So I've managed to actually modify the library. So at this point, I got the buttons working. So there's, the square, triangle, circle. There's kind of 4 buttons for directional and a PS button and a select button, and then the start buttons over here. So I have all those buttons working. However, there's obviously a gyroscope in this board. So when you tilt it, you can, you know, do different moves and stuff like that with the PlayStation games. Well, I'm trying to get it so it reports to the Arduino. And then it also has infrared sensors at the front, the back, and on the 2 sides. So if you do a hand grab, it's a light sensor that detects no light there. So then that should be reporting back as well. So I'm trying to get, I've been digging deep into USB protocol to figure out, how the code actually gets all these like signals back and forth. And I think
Great.
there's also, so yeah, I've kind of read up on USB quite a bit and figured out how USB works. And
Great.
so, yeah.
Good. That's good to hear. Glad you're progressing like that. That's it sounds fun what you're working on there. Good
Yeah.
job.
Thanks.
What was that development board you're using again?
So the
hat?
USB shield,
Yeah. What is that? Where's that from?
I got it from TKJ Electronics. I can put a link in the chat there.
TKJ Electronics. Okay.
Yeah.
And did you say you're working with Bluetooth or something?
Yeah, so I plug in a USB Bluetooth transmitter receiver into the USB port, and then
Okay.
it can use the Bluetooth. Although you have to be careful if you buy a Bluetooth receiver, you have to be careful which one will be compatible. I just happen to have one. I think it's a Asus Bluetooth, and it seems to work fine. So
Is that Bluetooth Classic or
that
Bluetooth low energy?
it might be the low energy one. They actually, like, in the documents somewhere they've specified that they specify some, although the documents are a little bit dated now too. But anyways, that link takes you to the website. It was 43. Wow, I paid 42 plus shipping US. I'm in Canada, so it converted to something a little more, but $42. And I had the pin. You can specify whether the headers are already soldered on or not. And so it's cheaper without the headers soldered on if you're okay soldering them on yourself. But I had them pre-soldered, so. But it's from the UK, I think.
Great. Graham, it would be great too if you put some of that individual parts and things like that in discussion of further discussion onto the Discord server as well. It'd be great if you get some commentary in there for everyone.
Sure.
So I haven't purchased a RC car yet, and so I had some questions about that. As you know, I already do build a lot of robots, and I've been working on a project. But this one does kind of pique my curiosity because the idea of hacking an RC car sounds like a lot of fun. But one things I was wondering about was the motors on there are um, they're usually the ones I've seen, they're pretty fast. I mean, can you change the motors? Is that possible? Can you like instead of trying to figure out what current and everything that you need for a driver, just purchase different motors for them? Or I'm not an RC person as far as RC
Oh,
cars.
right, right.
I
Yeah,
don't know
right.
much about them.
Yeah. Well, we're John, it isn't just you. We're all learning this. I am by no means an expert either RC wise or Arduino wise. I'm learning along with all of you. Okay, so that's part of the that's part of the fun and part of the challenge here. But as I said before, the best course is to buy something that's inexpensive.
Hmm.
Inexpensive as far as the overall sizing. Like now this unit, I mean, sure, this is an old, what it is I'm showing you here, what it is I'm in the process of modifying is an old Radio Shack model. So unless you find
Oh.
something like this on eBay, it's non-existent as far as being able to purchase these anymore. And this is a what's called a 1/16th scale
Hmm.
vehicle. Okay, so this is a nice small one. That's one of the reasons why I recommend something that's inexpensive, is because the motors are smaller, and therefore the power supply requirements are not real high, like a lot of the higher end remote control industry RC
Hmm.
planes, truck, tanks, cars are. Okay. And this is a real expensive type model that I recommend. And I know that there are lots of, in fact, if you go back, John, in the Discord server, I gave specific links I think it's posted in the resources channel of the server. I gave a bunch of various links that people can peruse as far as the types of vehicles that are good for a project like this. But if you look for something on number one on the overall cost side that's lower end, and then looking at the battery requirements, either the battery that literally comes with the purchase of the product itself, or the battery that you need to supply separately. You want something that is, sure, I know a lot of people go with LiPo batteries nowadays, and that's fine. I personally like to stay away from those because of the fire hazard with them. But you want to have something that will work with the rest of your technology that you've got in your workshop. Namely, you want to have a charging or batteries available to you that's not going to break your wallet, that type of thing. And then you need to look at for the battery pack itself. You want to note the uh the current requirements for it. Either if
I
we've
guess
got
one of
like
the, I
like
guess
like
the,
this,
I
like
guess the one thing I'm most concerned about or thinking about is the speed and torque of the motors. If I want the vehicle to go like at a certain speed or do a certain thing, um, am I limited just what that particular um, RC car or truck can do? Or can it be upgraded to a different motors? What, or maybe even can you install them with encoders also? Um, that kind of thing.
Mhm.
So, John, um, what I'm going to try and do, the first thing I noticed when I first powered this cheap car up is that it's way too fast. I mean, it's built
Yes,
as a
that's what I
rock.
was wondering about.
It's billed as a rock crawler, but you would not use this if it were full scale as a crawler because it would crash as soon as it hit any rock. So what I intend to do with my Arduino in between the receiver and the motors is to do pulse width modulation and to slow it way down.
Hmm.
Um, and that's not going to give a lot more power, but it has pretty good power, at least enough to, to drive through grass and stuff. So I think that that's the first step to try and see if what we've got is sufficient. And then if you found a situation where you needed more power than you could get that way, you might think about replacing the motors. Um, I hadn't thought about um, um, adding encoders. Uh,
Yeah.
Actually, for this RC car project, I mean, you're not going to do a lot of precision driving with Ackerman steering of an RC car. You'd have to actually the one I did 24 years ago. I think we did some uh, uh, autonomous sawing back and forth to turn in place. Uh,
Oh.
because you're stuck with the steering that you have, and we're when you're trying to compare that to the other kind of robot that we have a lot of experience with in the Seattle Robotics Society, which is a motor, two driven wheels, the left and right
Right.
driven wheel, and a caster. That's much better for turning in place and getting into tight spaces. Uh, uh, I think I've got my camera set up here. Let's see if I can make this go. So this is the car that I bought, and you can see it. It's a funny. It's a monster truck because the wheels are obviously much larger than that body would have on a normal car, and one of the things I liked about this is that it has a larger wheelbase than the body would have, and so that's more stability and more room to put stuff. So I took out four screws and the lid comes off. And underneath here, there's just a little piece of clear plastic that is slid onto the posts that the plastic posts in the top of the body or in the underside of the body, and that I think that was their simple attempt to keep dirt out of it, but it's not a seal at all. So I think in practice, if you took this out in a dirty uh, field or something like that, you'd get your electronics dirty. But the the one of the things I found out right away was that with this in place, there's lots and lots of room above it. So I'm considering a design that will put all the stuff inside the car, but I don't know if that
Mm.
that's pretty limited, I think. Um, and then here's the car with the lid off. And you can see it's just a tiny circuit board with a single 16 pin dip that is the receiver and drive electronics is all on that one chip. And
Well, I have a quick question. Um, so right now, all I see is a bunch of small squares. Is there a way, is there a setting or something I'm missing as far as to get what Doug is showing on my full screen?
oh, I'm sorry. Well, small squares.
Yeah,
And
maybe I have some setting I'm not doing correctly or
Are
something.
you doing speaker view
I
up in
don't know
the
what that, I don't know what
yeah,
that
up in
is.
the upper right corner of the Zoom window? There's a view,
Oh, okay.
and then hit speaker
Oh,
view, and then whoever is talking will be big.
it says gallery. Oh, is that what I want?
No,
Oh, that's much
switch to
better.
speaker.
Okay. Thank you.
Yeah, sure.
my hand here.
Oh,
Right. So, oh, here, let me do that again so you can see that. Here's the underside of that oh, here, I have to put this back down. Here's the underside of that car. So you can see that just has a clear plastic sheet in here that's been vacuum formed to have a bit of a shape to it. And that kind of fit over the top there when it was put together. And it when you put it back into place, it comes to a stop there, and there's quite a lot of space between that plastic insert and the top of the car. So there's a lot of room for, and of course, being a pickup, you could put something in the pickup bed too.
Mhm.
But and then here's the car itself. Everything is on that little circuit board with just a single 16 pin dip. It has quite a lot of length to the motor wires. I thought that was interesting. So I could either um, um, I don't know if I ended up with Donna's idea of a big board on top with the control electronics up there, I'd have plenty of wire to go up to that. Uh, I could either move the receiver board or leave it in place. One of the things, well, there's all sorts of things I like about this car. So one of the things I chose, this is a seven, I think it's 7.4, 7.2. I've forgotten exactly, but it's a lithium ion battery pack. And that voltage is high enough that with a low dropout regulator, you could get to 5 volts and actually use it for 5 volts. Although Don is right, one of the biggest problems we're going to have is if we had only one power supply, trying to isolate the power well enough that you could control electronics along with the motor. I'm going to give it a try because I've never actually spent that much work trying to use diodes and capacitors to see if I can, and maybe even DC to DC converters to see if I can isolate two power sources from one battery. Um, this car has good uh, pushy wheels. They have easy feel so that you get traction. It has good knobs and let's see. Oh, one of the I had no idea from the bill on this. I bought this from Amazon, so they have a big page of stuff but the things they don't tell you is, for instance, there's no differential in either the front or the back. So the wheels there's just a straight through axle, and that's probably all right for an off-road car. But if you were on a linoleum floor, you'd hear the wheels squeak, I think, when you made a tight turn. Um, the That's in the back. It's a single axle. Of course, in front, it has steering, and it's four-wheel drive. So I expected, because it said it was a two-motor system, to find an axle going up through here, with U joints or something to transmit the power from one motor to both the front and the back wheels. But instead, they've put two motors in it, and they're counting those as their two motors. They don't count the motor in the steering controller as a motor. But I'm going to need three motor controllers basically in order to control this. Um, so there's one cord that comes to the back motor here, and two separate cords that come to one to the front drive motor and one to the steering motor here on top. And you can see the steering motor just runs this little bell crank here and steers the wheel.
Nice. I love that platform, Doug.
Here's on the bottom is where the battery fits, and there's a door that snaps on there. Let's see. Oh, and it has some good springs too. I did some testing, and with it sitting on a table, you can lift it a good fraction of an inch before it starts to lift the whole car off. So that's some real independent suspension. Um, the way they do it is there are three control arms here that have a ball joint on either end, and then two springs. And so that gives it, and then of course I don't think the car is heavy enough to spring both the springs at once, but it's heavy enough that if you were on an uneven surface, one of the springs would go.
So could you drive both drive motors with one motor controller?
It's conceivable. You could just hook them both in parallel to the.
Yeah.
The first RC car I ever had as a little kid had a motor on each of the back wheels, and those motors were simply connected in series. And I realized that that works, right? If you have two uh, um, electrical devices connected in series, one can take more of the voltage you apply to the whole thing, and one less. And so two DC brush motors hooked in series is like having a differential. Of course, you'd have to have twice the drive voltage to do that. Uh,
Right.
but I'm hoping to get three controllers. I'm not sure. Yeah, you're right. It's kind of not necessary. Well, it depends. In the same way that we have a straight through axle from left to right, it might not matter too much. Well, I guess the one thing you could do with two separate motor controllers is you could carefully adjust how much power you're applying between the front and back motors. I don't know what good that would do in, well, what we intend to drive this thing. But basically, you could have a separate, pulse width modulation setting to decide how much power goes to each motor.
So Doug, have you actually driven this thing?
Well, that's the first thing I did is hunt down batteries for it because it came with a battery and it took less than the 3 hours that it said to charge it to get it charged. Oh, I should mention that so this little kit doesn't come with anything that plugs in the wall. What it comes with is this little USB, and you charge it from that. So I actually charged it from my laptop. Uh, and oh, this little controller has two lights on it. It has a red pilot light and a green, I think one way or the other anyway, green blinking light that blinks until it's charged. Oh, and here's the transmitter. Uh, pretty simple. It's got the trigger, and then oh, here I think I still have it open. Yeah, we can. Oh, if I can slide it apart here.
One
There we
thing
go.
I'm curious if that if the steering might already be driven by a servo, like an RC servo,
It,
because you could interface that directly to the Arduino.
I
You
believe
wouldn't.
I believe it is just a motor. And here's
Hmm.
what when I play with it and when I look in here, see if you look inside, what you see are on this half of the controller are the little wipers. There's a pair of wipers on the trigger here, and see how it is springs in there, so that it centers it between front and back limit. And then here's the little knob, and it moves this one way or the other with two springs to center it. And the other half, they've placed the printed circuit board with the traces toward the center, and they actually have PC board traces for those wipers to wipe on. So that that's how they built the what do you call it, the sensors, the switches. So they are simply switches. There's no proportional at
Okay.
all. And
Hmm.
that's the first thing I noticed before I started to take anything apart. I put batteries in and played with it, and it was pretty clear that when you turn the steering knob, it's either when you let it go, it centers and the wheel center. And by the way, there is a hand control here. Here it is, um, where you can carefully adjust so that when you're trying to go straight, it will actually go straight. They have a little I wonder what it does is it controls where it's probably mechanical. It controls where the centering is. But when you steer left or right, you hear the motor run that simply goes until it has taken the steering all the way one way or the other, and then it just kind of binds. So it's just a motor. But because it has a return spring, pulse width modulation ought to allow proportional steering. Oh, and finishing the description of this transmitter board. So they had to mount the board upside down, basically, from the way we're used to, right? To have the traces out in the middle where they could have the switch work on it. And so whereas they have a through hole 16 pin dip on the receiver, on the transmitter, they have a surface mount 16 pin chip. And so it's surface mounted on this side. You can look at it. Unfortunately, it doesn't have any numbers that I can read. And then on the back, they have things like the power switch and the power LED, which was mounted through hole, and then they bent it over the side so that it come out this way and go into the other side of it. Both of these have I think it was 16 megahertz crystal. I'd have to read it. I put it in my write-up. But they both have the same crystal. A little bitty short crystal, like a full width crystal, but only like a quarter inch or less tall. And then this transmitter takes AA batteries, so there's no rechargeable anything there. Although I suppose you could use rechargeable alkaline batteries. Oh, and I wanted to mention, so this thing comes with a screwdriver. This is the screwdriver that comes with it. It's a Phillips screwdriver, and ostensibly it's for opening the battery doors, right? They have one screw on each battery door, but all the other screws are accessible to this screwdriver. So your kid, if you bought this for your kid, the kid would play with it for a while, and when he got bored, he would take it apart to see how it works. It's amazing. It's a perfect thing for if you want the kid to learn that kind of stuff. Well, that's, I guess, what I wanted to show. Uh-oh, what happened to Donna? Let's see.
So you put that all on the Discord?
Yeah, I have a write-up in the resources
Oh,
section.
okay.
As I took it apart, I wrote that basically. I did. It's one of the utilities of that is so that I remember what it is I did. And so all of the directions for this thing are on the bottom of the box. I don't know if I can, yeah, just move this so I can see. Oh, and here's the other one, so you can actually see uh, the top of the box there. But this is the only directions that there are. Um, uh, the transmitter and receiver are 2.4 gigahertz, and automatically they pair when you turn them on. So you can have more than one of these, and they pick different channels. Uh, so that's kind of cool. I mean, in the old days, you had to like decide to have one 49 megahertz and one 27 megahertz because the receiver wasn't good enough to reject another channel.
Well, I love that design, Doug. It looks like a wonderful choice purchase that you made. One thing I was going to mention too, if you decide to keep that whenever you're doing your conversion,
Mhm.
and if space and remounting is allowed, uh, you might want to consider remounting that shell that you removed
Oh, the lid.
for the actual shell. Anyway, what I'm thinking about is the idea of the great extra cargo space that is afforded with that trunk that is on the. So that's just something to consider for if you need extra space or what have you for mounting other things that you can utilize that trunk as well. That's another great benefit of
Yeah.
that particular platform that you chose.
Well, the other thing I wanted to mention about screws is there's lots of things you can take apart. I haven't looked on their website, but they might actually have replacement parts for these control arms and stuff. Because I would assume that kids would slam this into walls and break things, and they've made some attempt to make it so that you can actually come and replace parts. There's all of these um, the front and back drive modules are just all put together with the same kind of screw. So you can take it apart and hop it up, or you know, with John's idea of replacing motors, you'd probably have to like make room for another kind of motor. But and of course, the reason I would always buy one of these is I don't want to have to try and mesh gears. That's a whole skill of its own.
It would be nifty to have four-wheel steering on something like that.
Oh, well, we Donna, I don't remember, why did we buy two cars? Is it so that if one dies, we can go to the other, or because what Steve just said, you could imagine making a version of this with two front ends.
Yeah.
Sure. It kind of looks like with all that screwing, the connections there, it looks like it might be symmetrical enough that you could just literally take the front end off another one of those kits and put it on the back end of that one, and then you'd have your four-wheel steering.
Exactly. There's a kind of a horn here that's mounted with two screws onto the central box, and this horn then accepts the two springs. So, and it's exactly the same as the one on the front. So yeah, you could easily just swap it around. You can see that the control arms are held with a piece of plastic here that's held on by four screws. So that can easily be taken apart and played around with. So a good hacker toy. Oh,
Yeah.
and the other
And you
thing I
can have
wanted
one truck with four-wheel steering and another truck with no steering.
to, right. And the motors have little plugs on them. So there's three plugs, one for each drive motor and one for the steering motor, and they're labeled on the circuit board. I think it's LR, uh, what is it? FR and BK, something like that, front and back. And here's the little 2.4 gigahertz antenna. So that's the other advantage of running at such high frequency is they don't have a big whip sticking out. Oh, and there's one more fun thing. There's an extra 4-pin connector here that was unused. That means they have another RC car or RC something that has LEDs. That's labeled LED. So that's well, up to 3 or more LEDs could be controlled from those 4 pins. And I don't know if I can figure out how to transmit that. I might. I didn't notice anything special in the transmitter. Oh, by the way, the transmitter, that there is that to mention, that beside the surface mount chip is a whole bunch of little surface mount discrete parts that are mounted on the PC traces there. So that configures it in some way.
That's great. I love that, Doug. So one thing I was going to mention before I forget about it, John was mentioning about he's wondering about the idea about the speed of the natural speed that, well, I mean, the way that the RC industry builds the traditional truck, crawler, and even airplane is for speed. You know, that's their ultimate goal, is to provide the thrill for the purchaser. So one thing that we as people who are converting these vehicles to to Arduino control, is that one thing I haven't mentioned yet is the idea about comparing a traditional motor controller to an RC industry ESC board. If you're comparing those two, taking into consideration everything that we've been talking about today for your ultimate decision for your motor control scheme, is if you're comparing a traditional motor controller board to ESC, is that in general with an ESC, just because of that speed dynamic that the industry imparts on all of their control components, is that an ESC automatically, if you plug that into your platform, is that you cannot get as fine a control, even if you're controlling that ESC by an Arduino, which is entirely possible, is that you won't get the finer tune control of speed, of gearing down the speed, and also being able to necessarily control the direction as easily as comparing that ESC with a traditional motor controller board. So, that's another consideration here for the conversion methodology that's used. So ESCs are not as flexible for our needs is what it is I'm getting at. Okay.
Donna, you're planning to talk about pulse width modulation at some point, right?
I'm so oh yeah, I'm talking about yeah. So yes, PWM is heavily involved in for doing all of these communication schemes for either the motor controller board or for ESCs. Yes, PWM is involved here.
So that's a concept that inexpensive robot builders need to know a lot about because it makes up for a lot of problems.
Mm-hmm. Mm-hmm. Right.
Makes up for the fact that we really don't have analog speed control uh, likely, and we don't want to use analog speed control. We might use uh, like you could imagine a motor control module, which you might send it an analog signal to say how fast you want to go, but you'd still want that motor controller to use pulse width modulation to drive the motors because they're more powerful with pulse width modulation, and and you don't waste the power if you're trying to uh, uh, adjust the voltage between the battery and the motor. Excuse me. There we go. If you try to adjust the voltage between the battery and the motor, um, uh, uh, putting out a variable amount of DC, well, you can do that with a what would you call it, a DC to DC converter, but the DC to DC converter is using pulse width modulation to do that voltage control. So it's good for us to learn about pulse width modulation.
Mm-hmm. Right. Great. I'm glad you got such a great platform, Doug, to be working from. That looks great. I love your choice. Yeah, I've got something like that as well. I've got other platforms, RC platforms as well that I'm doing robotic projects on too. But I wanted to start for this context within this group. I wanted to work on something smaller scale. That's why I chose the platform that I did for this. And like I said, next month we'll be diving more into the actual hardware design for motor controls and all that. So be sure to between now and the end of August when we meet again, do some do some research as far as your particular platform that you purchased or that you want to purchase, and go ahead and do some actual measurements to identify what a great for uh, a workable motor controller board or boards for your platform. Go in and do some purchasing there so that we can actually start working together to put the hardware and software together for the motor control, and then also decide on what you want to do for autonomous versus wireless control, whether you want to have the user selectable method or you just want to go totally completely eliminate the wireless section of the motor control and only go with the Arduino / autonomous control for the motors. So we all have some important work to do between now and next meeting. So okay.
Oh, I wanted to mention when you were talking about the motors as a shared resource, I thought, well, brute force, if you wanted to switch between autonomous and RC, you could imagine like unplugging the RC and plugging in the autonomous, or you could imagine like a four-pole double throw switch that would switch between the two.
Yep.
But
Yep.
what
Yeah,
I
we're good. Yep. Yeah, Doug, we'll be getting into all that next
all
month.
right.
So yep. Yeah, lots of fun stuff coming with that. Really looking forward to it.
In the
Okay.
remaining minutes, I could probably share what I have if you'd like.
I'm
Go.
sorry, Doug. What was your point, or what was your question?
In the remaining minutes, I could share what I have if you'd
Oh yeah,
like.
please do.
Yeah,
Yeah, go right ahead.
let me just see. I guess I can't share. Oh well.
Oh, okay. I'm sorry. Excuse me. I
No,
thought
no
I
problem.
thought I thought that everybody could. Excuse me. So sorry. No, multiple participants. Yeah, yeah, no,
Okay.
you can share.
So can you see that? Okay, so probably not, but this is my two-wheel self-balancing robot. So what I did was I took an existing two-wheel robot and pulled the motors and the tires off it and just used that. And the rest of it is all my creation. So I've been working on this for quite a while. It does run, but not really well. So I'll plug it in. Oh, you hear the motors. I don't know if you can hear the motors going, but they are running. So what I did is for the chassis, what I did is I just took a piece of aluminum and from hardware stores, like a just a real small sheet of aluminum and just bended it around a 2x4 and created my chassis that way. I am interested in you mentioned a wood platform. Do you usually use wood for robots, or I've heard of like using Lexan and things like that. I mean, what are some of the materials you can build it out of? Can you hear me? I guess not.
I'm sorry, Doug. The audio is just not coming through for me, and
Oh,
that's just something I guess that's on my side. It's hard for me to understand what everybody's saying. So
hmm.
I apologize for that.
Oh, no problem.
So Doug, uh, let's see. In the Seattle Robotics Society, we have people all the way on one end. There are people that will use double stick tape to hook hobby servos to an old CD to make their robot. And on the other end, we have people that hand build their own CNC mill to use to build parts for their robot. So, and everything in between. So you can imagine anything that you can buy, borrow, or dumpster dive can be used to build a robot. And I wanted to say about your balancing robot. What I notice is that you have a very short robot, and
Yep.
my intuition is that the shorter the moment arm, the harder it is to balance. You might try the easiest thing might be to move the battery about a foot taller than that robot. Just have the battery have a tall body with the weight at the top, and you'll find that it's much easier to balance.
Yeah, that's what I've heard. And yeah, so I'm just my construction skills are a little limited. So that's why I asked about the materials. Like, I'm basically looking for stuff that's already built, like I don't know, Lexan or something that I could use to, just kind of bolt together a robot rather than just putting it through machinery, which I don't have.
Right. So, you said you used sheet metal as aluminum
Right.
or steel?
Yeah, this is aluminum, very, very thin aluminum. It's pretty flexible, so it's very easy to bend.
Hmm.
And I can drill holes in it pretty easy. So,
Mhm.
and as far as the circuit board, so what I did was, yeah, I'm using PWM, and so the motors have what's called quadrature um, encoders on them. So I just use that, and I've got, unfortunately, the CPU here, the Nordic CPU, it only has one quadrature decoder, so I can only read the motor speed on one motor rather than both of them, which I really want. Um, yeah, and then let's see what else. Yeah, the circuit board. So what I did is I took a Adafruit Perma board. It's like a breadboard that you can use to mount components on. It works just like a breadboard, so that you can solder components on it. So it's really useful for if you have like breakout boards you want to solder together. That's what I did on this, and it works really well. And on the backside, you can either do soldering, or what I did was called wire wrapping.
Hmm.
Basically, stick there's I don't know if you're familiar with it, like in the 70s and 80s, they used to do a lot of wire wrapping, and it works really well for doing very quick connections, and you can change the connections very easily on it. You don't have to solder and desolder stuff, which is, if you make a mistake or something like that. And then I do have the motor controller. I have a Pololu motor driver. I know Donna mentioned that as a supplier before. I bought this like a year ago, and so yeah, that works really well. And I've got some other components on here, but I think I'm out of time, so that's what I have.
You should you should learn how to listen to your encoders directly with input pins on your microcontroller. You should be able to do that. You shouldn't
I,
have to use a quadrature sensor. It's harder to do it by hand than to have a quadrature sensor, but it should be possible as long as you've got a fast enough processor speed.
well, the Nordic chip, it has built-in support for quadrature decoder, so yeah,
But
it's
you
basically just a matter of using the software libraries with that to read the wheel speed on it, so I can get a precise determination of what the wheels are doing on
right,
it.
but you're only doing it with one of the motors though.
Yeah, that's true.
So you could, for instance, well, let's see if I'm trying to figure out how you could bridge across from some other inputs to uh to to spy and see what's going on, but uh to learn how to do it yourself is the idea. There should be a way. What the quadrature detector that's built in there, it saves you some processor cycles and stuff that's done in software. It does it in hardware, or it has
Right,
built-in library that does it. But you should be able to figure out how to do that yourself for the other motor.
right. Yeah, that's one. Yeah, I know. I understand what you're talking about. Like just using GPIO, bit banging it, right?
Yeah, yeah.
Mhm. Yeah.
Okay, yeah,
I
sure.
had back when I was using basic stamps, I ran into a basic problem in that the basic stamp can only run on the order of thousands of instructions per second rather than millions. And so if it didn't have a built-in protocol, like it had a built-in protocol for serial, but it didn't have one for USB, and it didn't have one for a PC keyboard. And I tried to bit bang a PC keyboard, but it was just too slow. But
Actually, the same guy that wrote the PS3 code also did a balancing robot, and he's got a YouTube video, and he explains, I think, some of the problems that he ran into that you're having and how he may have solved them. So I just posted a link in the chat there that
Oh,
points to the one he did.
right. Thank you. Yeah, I've been reading a lot on that topic, so yeah, I'm aware of the tall robot thing and the PID tuning and all that. So yeah, and I've also got a Bluetooth setup, so I've been able to control the robot remotely with Bluetooth and also read the status of the robot, what the robot is doing, like the accelerometer outputs, gyroscope, magnetometer, all that stuff, and so I can switch between autonomous control and then manual control of the robot parameters. So it's pretty easy to use on Arduino, Bluetooth low energy. Anyways, that's all I have. Thanks for
Great.
listening.
Great job, Doug.
Thank you.
Good progress on your project.
Thank you.
Okay, so guys, we're at the top of the hour. Anything else that anybody wants to share, or any questions? Again, after the meeting, I'll upload this video to the YouTube channel, and I'll also put any resources, etc., onto the Discord server. So I hope everyone enjoyed this. I know I did, and I was happy to see all the communications and sharing of information. I was very encouraged by that. Thanks so much, and I look forward to all of that continuing. Okay.
Thank you.
Yeah, thanks. It's been fun. Everyone have a great rest of the day and a good rest of the weekend.
Thank you, Donna.
Thanks, Donna.
Yep,
Thanks,
you bet.
Don.